Hi. Some of you may already have guessed that I'm a bit of a Milwaukee fan, and that's what we've got to have a look at today. A Milwaukee fan. Now, I purchased this off eBay some time ago. I think I paid a bit over the odds for it. I think it was about £46 or so. I'll just bring the listing up, you can have a look. It came with the power pack in the box and the instructions. It doesn't look like it's had much use. It looks pretty brand new, I would say. There's very little dirt or anything on it. However, it seems to work on the position 1 and position 2, but it cuts out on position 3. It just literally comes on for a second and then goes off. So I don't exactly know what the problem is with it. It might be a difficult one, or it might be a bit of a breeze to fix. So before we get into it, we'll just plug it in and we'll see what it does. So I'll just plug the mains lead in here. So that was on position 3. We'll try position 0 first, then 1. So that's 1. Position 2. And then 3. It just briefly goes and cuts out. Let's show you that again there. So 0, 1, 2, and it just cuts off. So, right, how do I get into this then? I think I'm going to start by taking out these screws around the bottom there, which are Torx. So, it looks like we've got a bit of a circuit board down there. This looks where the power comes in from the battery. The mains comes in here. That's one thing we didn't try. We didn't actually try it on a battery. We'll see if it does the same thing on the battery, because it could be something to do with the power pack. So, let's just see what it does on the battery. A fully charged battery there, and that was on 3, and it does the same again. So it does the same on mains and battery. It's a little bit awkward to work on this with it being up in the air, but right, let's have a little bit of a zoom in on this circuit board and see if we can see anything obvious. Right, well, I can't see any obvious burnt components or anything there. Just at first glance. Let's see if we can zoom in a little bit more there. So these wires here look like the ones coming from the controls of the fan. It looks like they go through some resistors and diodes, and then into this small IC here. I've got another larger IC here. I'm not sure what that one is. I think this must be M1, so I guess that's where the motor is, so that must be the output. Looks like the battery comes in here and here. Possibly a fuse there. And I think that's about it, really. Looks like we've got a MOSFET here, and that'll probably be to switch the motor on and off, I guess. Right, give us 2 minutes, I'll have a quick look over this circuit and just see if I can see anything obvious and see if I can work out exactly how it works. So I've had a little look over the circuit. One thing that I've noticed in this circuit, there's no microcontroller, it's all just analog chips. This is a 555 timer here, and what that does, depending on what speed selected, it gives a square wave output on this pin just here. I'll get the scope on and you can have a look in a minute. And what happens is when it's on speed 1, the waveform's about 50% duty cycle. That means it's half on and half off. When you put it onto speed 2, it's about 75% duty cycle. That means it's on 3/4 of the time, and then it's off 25% of the remainder, and then on another 75% of the time, and then off 25% of the time. And on speed 3, it's on just about continuously. You can see a little tiny blip in the waveform, but that's about it. But like I say, I'll show you that in a minute. This section over here seems to do with the battery voltage level. So what happens is, if the battery voltage drops below a certain voltage, instead of it damaging the battery, it then switches off this MOSFET here and pretty much disconnects the power. So I think that's what this section does over here. This section over here, where we've got an IC here, which is an LM324, that seems to be being used to detect current. So I've done a couple of little tests as well. If you jam the fan, it cuts off, like what it does when it's when you put it onto speed 3. So it's kind of like either this bit of circuit's too sensitive, or the motor's drawn too much current. It's a little bit weird. This resistor here, I think they're using that to actually measure the current. It's like a current sense resistor, and it seems to feed back, I think it's from, I can't remember which line it is, it's one of these 2 lines here, I think it's that one actually, and then feeds back through a few resistors into this op amp, which it's kind of using as a comparator. So it checks basically the voltage level is against a preset one, and if it's over that, it then basically disconnects the power to the motor. So I think that's pretty much how it works, or a rough explanation in any way. Right, so I'll hook the scope up and I'll show you what I found. Right, so I've got the scope up there now. So if I go onto this pin here, and we'll just switch the fan on to speed 1. And you can see the waveform there on the scope. And if I go on to speed 2, you'll see the bit that's up, which like the peak of the waveform gets slightly wider, like that. So that's speed 2, and that's speed 1. So speed 1, it's like on, off, on, off, on, off. Speed 2, it's like on for a longer time, so it's sending more power because it's switching the MOSFET's on more of the time. And then when we go on to speed 3, where it cuts off, as you can see, it's on pretty much all of the time. It's just off a very tiny portion of the time, until obviously it trips out. Right, let's have a look at this part of the circuit then. So I think this bit over here is what it's using as a reference. I think it's that pin there, if I remember right. I'll just try it. Could be wrong, could be that one then. Yeah, it just seems to cut off. Nothing much going on that one. Let's see what we get on this fit. Yeah, that's the waveform again. So that's obviously driving the fit. So we seem to either have something going on with the motor or something going on with the detection here. I wonder if I can see how much current that motor's drawing. The power supply is rated at 2.5 amp, so I would have thought the motor is going to be drawing less than that. Right, I was just thinking about taking this board out, but I think there's not a lot of room on these wires here to try and measure things. So what I'm going to do, I'm going to try measuring across this resistor here, because that's what the circuit's using, I think, to measure the current going to the motor. Just get this wire out here. So if we put the meter onto volts, and that's a 10 ohm resistor, is that? Ah, no, 1 ohm resistor, sorry. Yeah, so 1 ohm. 0, 1 and no zeros. Well, it's measuring 0.3. I mean, I've got a bit of a tolerance on them, I know, but let's see if we get any voltage across that when it's running. I'll try not to short anything out. .9. So does that mean it's drawn 1.4 amps maybe? And there it's drawn 0.9 of an amp maybe? And it went up to about 0.27 there, so does that mean 2.7 amps? I think that's what it does. I might need to look that up just to double check. What about measuring the resistance of this motor? .5 ohms. I'm not so sure on this one. I mean, it doesn't look that old, so unless somebody's poked something in the fan and had it jammed for quite a length of time, I wouldn't have thought, well, it cuts off, so it couldn't be that. I'm just trying to think if there's, you know, fault on the motor or fault on the circuit maybe, or is it trying to push too much air with the motor that's not big enough maybe? Because I have seen a few of these on eBay with the same fault, so it seems to be quite a common thing. I'm just wondering if they've under-specced the motor or something, or got too big of a fan blade on and it's taking too much torque or something, or Trying to push too much air. I'm just trying to think how I can measure the current. I know what I could do. I could use the bench power supply and put a jack into there, and that would tell us how much current it's drawn. Right, I'll do that and back in a sec. Right, so I've got the bench power supply hooked up, and I've got it set to 18 volts. So let's see what it does when we switch it on. Right, well, it's drawn 0.9 of an amp on the bench power supply. I know you can't actually see that at the moment. I wonder if I can use that camera and we'll get the bench power supply shot in as well. Right, so I've got the bench power supply on there now and recording, so you can see what's going on there as well. So we're drawing 0.9 of an amp, so I'm just going to measure on this resistor here. Let's get that wire out of the way so you can see the meter a bit better. I'll just measure on this resistor, and if I'm right, we should have about 0.9 of a volt there, and we do. So that's how it's measuring the amps, by using the resistor and converting it into volts. So if we turn this up, we're now drawing 1.4, about 1.4, 1.5 amps. Yeah, and the voltage on the meter about corresponds to the amps being drawn. Right, so let's see how many amps it draws when I turn this up. Yeah, goes up to about 2.5. So it is drawing too much current, but I don't know why. So that's the problem. We're drawing too much current, but I don't know why we're drawing too much current. Is it a partial short on the motor? Yeah, well, we'll just turn the amps up on the power supply and we'll just see how many it actually does draw on full. About 2.5. It's 2.7 there. I wonder if I power the motor direct. So hold on. Right, if I go on to amps DC, now it's just going to be negative switched, I would have thought. Yeah, so I'm just using my meter as a short to just to connect the negative instead of it going through the fan. I'm just connecting it directly there, so it's not actually drawn that much out of the way. I mean, it's drawn about 2.5 amps there, so if the motor was short, I would have thought it would be a lot more. So, but it's kind of on the limit of the power supply. I wonder if we can lower the duty cycle of this by changing one of these resistors. So instead of it being at, let's say, like 100% power, it's at something like 95%, so it's just under where it trips out. Right, I think I might have a look at that. I'll just pull up the data sheet for the 555 timer and I'll be back in a sec. So I've removed this resistor here, R12, and that was a 220 ohm resistor. Now I've tried a 4.7k in there and it was a little bit better but not quite, so I'm just going to put a 10k in now and we'll see what that does. So So let's get the rework station out again. Right, I think that should do. Right, I'm going to hook it up to the bench power supply again, and then we'll be to monitor what current's being drawn as well. So we'll see what this does now then. So that's the first speed. Right, we'll just zoom out a bit. Right, so that's the first speed, and it's drawn 0.9 of an amp. That's the second speed, and we're drawing about 1.3 amps. And that's the third speed now, and we're drawing just under 2 amps. With the 4.7 K resistor, it was drawn just over 2 amps. It was about 2.2 amps it was drawn, and it was tripping out. So I'm still not 100% with this, whether there's possibly, I don't know, I don't think there's a short on the motor, but that's the only thing I can really think. Right, there must be something. Well, anyway, we'll pop it back together and we'll give it a test, and then we'll take it from there. Right, we'll give it a test. That's speed 1, speed 2, and speed 3. Right, we'll try it on the battery. Right, I think we'll call this a fix, although I'm not so sure whether or what the exact problem with it was. Was it the fan is putting up too much wind resistance and it's stalling the motor? Is it the current sense circuit too sensitive? Is it a fault with the motor? I don't know. What do you think? Leave it in the comments below if you've got any ideas. Right then, if you like this video, give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.